Hello, for this worked example, what we have is the same robotic arm we had in the last problem. So it's still fixed to the floor, this orange part, and we can rotate it upon point A. Section AB is 3 feet long. We can also rotate about point B. Section BC is 2 feet long. And we've got the end effector right here at C. So for this problem, we currently have theta is equal to 30 degrees, phi is unknown, but point C, we know that is currently on the x-axis, and it's moving towards the origin point, so moving to the left at a rate of 1 foot per second. So we want to know what are the angular velocities that we would need at points A and point B to make this happen. All right, so step one in this whole operation is going to be to figure out what is angle phi right here, since it's not given to us. And that's going to be simple enough. We're going to use the y position of point C to figure that out. So the y position of C is currently just 0, but we're going to go up by 3 sine 30. So we know this is 30. And then we go down by 2 sine phi. All right, so this must be 0. All right, so if I move 2 sine phi over, I've got 3 sine 30. I'm going to divide by 2, take the inverse sine of that amount. I could find that phi, that angle, is equal to 48.6 degrees below the x-axis. All right, so next up, what we have is we want to figure out the velocities. So for this, we're going to need the directions. So I'm going to draw in my r and theta directions. My r direction for section AB is going to be UR1, and then theta direction is going to be going 90 degrees from that. So this right here is just 30 degrees. It's the same as theta. And then 90 degrees up. So it'd be 30 degrees from vertical, or I'm going to draw this in as 60 degrees from horizontal in the other direction. All right, so that is my UR1 and U theta 1 directions. Down here, my UR2 and 90 degrees counterclockwise from that, U theta 2 directions. This is going to be down this way. It's my 48.6 degrees. So my solve for is the same phi. And then here, it's going to be 90 minus that amount. So 90 minus phi would be 41.4 degrees. All right, so that's my r and theta directions for each of the sections. All right, the equation I'm going to use for all of this is the velocity of C with respect to A is going to be equal to the velocity of B with respect to A plus the velocity of C with respect to B. So I will need to expand that out, but I've got the information I need to put this together. So let's go to the next slide for this. All right, so the velocity, actually, let's copy this over so we have it available. All right, so what I know is actually I know the final velocity of C with respect to A. I know that it is -1 foot per second in the x direction, so that is the I unit vector. So that is going to be equal to 2 simple rotations. So R1 theta dot 1 in the U theta 1 direction plus R2 theta dot 2 in the u theta 2 direction. All right, so let's draw in the directions and add amounts to all of this. So this is -1 in the I direction. It's going to be equal to r1 theta dot 1. So I know r, it's going to be 3, but I don't know theta dot 1. So I have an unknown value in that. And then the u theta 1 direction, that was going kind of 60 degrees up, kind of in negative x direction, positive y direction. All right, so I also had 2 times theta dot 2. This is a theta dot and phi dot, or theta 2 dot and phi dot would be the same value. So I'm going to write this in as negative phi dot. And it's negative because a counterclockwise rotation is actually going to make phi smaller. So phi is measuring down, counterclockwise rotation will be going up. So we want to put the negative sign in there. And then the u theta 2 direction is going up. And we determined that that was 90 minus our phi angle, which is 41.4 degrees. All right, so this needs to get broken down into x and y pieces. So the x component, I'll say VCX is going to be equal to -1, which is equal to -3. So I get a negative sign from the direction. So -3 cosine 60 times theta dot minus, and it's going to, I've got a negative sign this time from the phi dots. So -2 cosine 41.4 times phi dot. All right, so that's one equation that I've got right here. And I've got 2 unknowns, so I can't solve it yet. But I also have VCY. So the y velocity of point C was equal to 0, but is also going to be equal to 3 sine 60. So become vertical component of that times theta dot minus, so I've got a negative from here, positive from there, so -2 sine of 41.4 times phi dot. All right, so that is a second equation. And what I need to do at this point is simply solve my 2 equations for my unknowns. So I'm going to take the y equation first and kind of simplify that down. If I take that y equation and solve for phi dot, or sorry, solve for theta dot, I would find theta dot is going to be equal to 2 times the sine of 41.4 times phi dot over 3 times the sine of 60. And so further simplify this down, it is 0.509078 times phi dot. Theta dot is 0.50978 phi dot. All right, that gets substituted in to my x equation. So I take this and sub it in for theta dot. So I get -1 is going to be equal to -3 times the cosine of 60 times 0.509078 phi dot minus 2 cosine of 41.4 times phi dot. Solve this for phi dot. So if I simplify this down, solve for phi dot, I would find that phi dot is going to be equal to 0.442 radians per second. And that is positive, but phi dot, if this is phi dot is phi is getting bigger, and so as phi gets bigger, it's actually rotating counterclockwise. So this is going to be a clockwise, or sorry, is rotating clockwise. It's going to be going in that direction. If I take this, plug it back in up here, so multiply this by 0.509078, I would get theta dot is equal to 0.225 radians per second. So this is also listed as positive, but if theta is getting bigger, we can see that this is rotating counterclockwise. So this one's actually rotating counterclockwise, like so. All right, so that is the angular velocities. This is joint A, this is joint B, that I would need to achieve in order to have my end effector C move vertically along the x-axis. All right, so with that, that's all we have for today's problem. Thanks for watching. Hope to see you again.